Hello, welcome to Miss YY channel. Today we are going to discuss chapter 3.1, Avogadro number and molar mass. The objective of our session today will learn how to define the mole in terms of mass of carbon-12 and Avogadro's constant. And also we will relate Avogadro's numbers with molar mass and molar volume at STP, which means standard temperature and pressure, and also room temperature. So basically in this chapter, there will be a lot of calculation involved and you have to remember some of the formula. So the definition of mole can be defined as any substance that contain the same amount of particles as there are in exactly 12 grams of carbon-12. So means that in 12 grams of carbon-12 is actually equal to 1 mole of carbon. So any substance which is 1 mole will contain the same number as the 1 mole of carbon-12. So the number of particles here we can also refer to atoms, molecules, molecular units and ions. And as we know, 1 mole of carbon-12 will contain 6.02 times 10 to the power of 23 carbon atoms. So based on this definition, I can say 1 mole of oxygen atom also contain 6.02 times 10 to the power of 23 number of oxygen atom. So 1 mole of any substance will contain 6.02 times 10 to the power of 23 number of particles, same as what is in the 12 grams of carbon-12, which is equal to 1 mole of carbon. So here are the examples. 1 mole of carbon-12 is equal to 6.02 times 10 to the power of 23 carbon atoms. So 1 mole of carbon dioxide molecule is equal to or contain 6.02 times 10 to the power of 23 carbon dioxide molecule, and 1 mole of chloride ion will contain 6.02 times 10 to the power of 23 chloride ion. So it means that 1 mole of any substance actually contains 6.02 times 10 to the power of 3 of number of the particles. So the particles can be atoms, molecules, ions, and so on. So the next one, the diagram here shows us the relation between Avogadro's number with molar mass and molar volume of gas at the standard temperature and pressure. So these are the conversion. So for example, if I have number of moles of certain atoms, so if I want to find the amount of particles in that atom, I can multiply by the Avogadro numbers, which is 6.02 times 10 to the power of 23. So if the question gives the amount of particles and we want to find the number of moles, we can divide by Avogadro number. And how about volume of gas at STP? So we can multiply by the molar volume, which is 22.4 to get the volume of gas at STP. And if the questions give number of mole and we want to find the mass of the atom or molecule, we can multiply by the molar mass. So if you want to find the number of mole, we can do the vice versa, which is mass divided by molar mass. So this is just a summarize of the formula which we are going to learn in 3.1. Now let's look at the example of questions when there is 1 mole of water molecule. So based on the diagram, we can see 1 mole of water molecule is made of 2 hydrogen atoms and 1 oxygen atoms, and H2O is a molecule. So the first question, how many water molecule, how many hydrogen atoms, how many oxygen atoms, and how many atoms in 1 mole of H2O molecule. So based on this type of question, the question is asking about number of particles such as molecule, atoms, and atoms. So we can do the calculation based on the formula, which is number of mole multiplied by the Avogadro numbers is equal to the number of particles. And the Avogadro numbers is also equal to 6.02 times 10 to the power of 23. So the Avogadro number is a constant value. So first questions, how many oxygen atoms are in 1 mole of water? So we can use formula number of mole multiplied by the Avogadro constant. So we can do the stoichiometry relation, which is 1 mole of water contain 1 mole of oxygen atom. So 1 mole of oxygen atom multiplied by the Avogadro numbers, we will get 6.02 times 10 to the power of 23 oxygen atoms. And how about hydrogen atoms? So 1 mole of water contain 2 mole of hydrogen atoms. So we have 2 mole hydrogen atoms multiplied by the Avogadro number, which is we will get 1.204 times 10 to the power of 24 hydrogen atoms. And how many water molecules in 1 mole of H2O? So 1 mole of H2O is equal to 1 mole of water molecule. So number of mole multiplied by Avogadro number, we will get 6.02 times 10 to the power of 23 water molecule. And the question D, how many atoms? So in the H2O molecule, we have 3 atoms, which is made of 1 hydrogen, 1 oxygen, 2 hydrogen and 1 oxygen atom. So there are 3 atoms in 1 mole of H2O molecule. So 1 mole of water molecule contains 3 mole of atom. So number of mole, which is 3 multiplied by Avogadro number, we will get 1.806 times 10 to the power 24 atoms in 1 mole of water. So to calculate the number of oxygen atoms in 1 mole of water molecule, we can use the stoichiometry relation, which is 1 water molecule is made of 1 oxygen atom. So to calculate the number of oxygen atoms, we can use number of mole multiplied by the Avogadro constant. And here we also multiply by 1 because there is 1 oxygen atom in 1 water molecule. And we will get the answer, which is in 1 mole of water molecule, it contains 6.02 times 10 to the power of 23 oxygen atoms. Next, we are going to discuss about molar mass. So molar mass can be defined as a mass of 1 mole of any substance. So the molar mass of any substance is numerically equal to its relative mass. So for example, relative atomic mass of magnesium is equal to 24. So therefore, the mass of 1 mole of magnesium is also equal to 24 grams. Thus, the molar mass of magnesium is equal to 24 grams per mole. So, relatively, they are same in number but different unit. And example 2, molar mass of CH4, okay, methane. So, to calculate the molecular mass, okay, we are using the sum of the atomic mass of each atom. So, 1 carbon 12 plus 4 hydrogen is equal to 16. So, this is a molecular mass for CH4. And the molar mass is equal to 16 grams per mole. So based on 1 mole of methane, the mass is 16 grams. Now we are going to try a few questions related to molar mass. So in 14 grams of nitrogen molecule, calculate the number of mole of nitrogen molecule if the molar mass is 28 grams per mole. And then further on, calculate the number of molecule and number of atoms. So the formula which is related to molar mass we can use is number of mole multiplied by molar mass, and then we can get the mass. So in question A, we are given mass and molar mass. So to find the number of mole, we can rearrange the formula into number of mole is equal to mass divided by molar mass. So the mass is 14 divided by molar mass 28. We'll get the number of mole is 0.5 mole of nitrogen. So based on the number of mole given, we can further to calculate the number of. Based on the calculation in 1A, 14 gram of nitrogen molecule is also equal to 0.5 mole of nitrogen molecule. So to calculate the number of molecule, we can use formula mole multiplied by the Avogadro number, which is 0.5 mole multiplied by 6.02 times 10 to the power of 23. We can get 3.01 times 10 to the power of 23 nitrogen molecule. So in the question 1C, we want to find the number of atoms in 14 gram of nitrogen molecule. So 14 gram is also equal to 0.5. So to find the number of atoms, first we need to find the number of mole of atoms. So we can use the stoichiometry relation, which is 1 nitrogen molecule contains 2 nitrogen atoms. So based on questions, if we have 0.5 mole of nitrogen molecule, how many atoms are there? So based on this stoichiometry relation, we do the cross multiply, which is 0.5 multiplied by 2 divided by 1. So we can find that in 0.5 mole of nitrogen molecule, there are 1.0 mole of nitrogen atoms. So the number of mole of atoms multiplied by Avogadro number, so we can get the number of atoms is 6.02 times 10 to the power of 23. Molar volume can be defined as the volume of occupied by one mole of any gas under the same temperature and pressure. And there will be two conditions, which is STP, refer to standard temperature and pressure, at 0 degrees Celsius and 1 atm, the gas will have a volume of 22.4 dm3, and at room temperature, which is 25 degrees Celsius and 1 atm, 1 mole of any gas will have the volume of 24 dm3. So based on this information, 1 mole of any gas at the same condition will have the same volume. So for example, 1 mole of oxygen gas at STP condition will have 22.4 dm3 volume. Same to 1 mole of hydrogen gas at the same condition STP also will have 22.4 dm3. So sometimes students will confuse what's the molar volume for STP and room temperature. So for room temperature, okay, so you can see that the temperature is hotter, okay, is higher. So when the temperature is higher, the gas tend to have higher kinetic energy, and they will vibrate, and the space between the gas molecule is further. So at room temperature, the volume is slightly higher than the condition at STP. And the formula used to calculate the volume of gas is equal to number of mole multiplied by the molar volume. So which molar volume we use, it had to depends on the condition. So let's look at the example questions involved with molar volume calculation. A sample of carbon dioxide has a volume of 56 cm3 at STP. So calculate the number of mole of gas molecule, the number of molecule, and number of oxygen atoms. So these are the unit you need to be aware. So cm3 is also same as ml, and dm3 is equal to liter. So based on the molar volume, the unit we are using is dm³, so you need to convert cm³ to dm³, which you can divide by 1000. So these are the conversion. So to find the number of mole of gas molecule, we can use the formula, which is volume of gas is equal to number of mole multiplied by the molar volume. So the volume is given, and the molar of volume at STP is 22.4. So we can rearrange the formula, which is number of mole is equal to volume of gas divided by the molar volume, and substitute the information. So the volume of gas we have converted into dm³, and divide by the molar volume, which is 22.4. So we will get that the mole of carbon dioxide gas is equal to 0.025 mole. So means that 56 cm³ of carbon dioxide gas at STP is also equal to 0.0025 mole of carbon dioxide gas. So to calculate the B, the number of molecule, we can use the mole of carbon dioxide multiplied by the Avogadro number, which is equal to 1.505 times 10 to the power of 21 carbon dioxide molecules. And for the part C, number of oxygen atoms. So to find the number of oxygen atoms, we can use the number of mole of oxygen atoms multiplied by the Avogadro number. So now we need to find the mole of oxygen atom first. So based on the stoichiometry, 1 mole of carbon dioxide molecule contain 2 oxygen atoms. So the question, we have 0.0025 of carbon dioxide molecule. So it contains how many mole of oxygen atom? So we can use the cross multiply method, which is 0.0025 mole multiplied by 2 divided by 1, and the number of mole of oxygen atom is equal to 0.005. So now we have the mole of oxygen atoms, and we multiply by the Avogadro number. So the number of oxygen atoms is equal to 3.01 times 10 to the power of 21. If you like my videos, please click like, share and subscribe. Thank you.